Hello everyone, so today we are going to look through the relevance of Antoine equation as it relates to a phase diagram of a pure substance. So last time we looked through the phase diagram for the water. So for this question, let's suppose we have the same container of water. So we'll have a container, so it'll be filled with water. So we'll have water in its water phase, and we'll have water in vapor phase. So let's say we have the temperature above 100 degrees Celsius. So let's say we have temperature of 120 degrees Celsius, and the volume of water inside of the container is 1 meters cubed. And let's say we have total of 1 kilograms of water. So what can we say about the pressure of it? So as the temperature is higher from the boiling point, when we look at the phase diagram, it's gonna be something here. So the pressure is not like 1 atmospheres anymore. So it's gonna be higher. So, but as we have some water in its liquid state, we cannot calculate it straightforward. So we have to look through something. We need to find the partial pressure of the water in order to find the pressure for the container. So in order to determine that, we're going to have to look at something called Antoine equation. So it is, as you can see, Antoine equation is a class of semi-empirical equation. So which means by semi-empirical, it means some of the equation is determined from the experimental data, and some of it is determined by thermodynamic determination. So as you can see here, this is our Antoine equation. But for this, we have the relationship between the pressure of the substance and the temperature. But we have these values A, B, C. So today we're gonna look at how to obtain this A, B, C values for a specific substance, so that with two methods. So we're going to use both linear and nonlinear determination of A, B, C. So for coding and nonlinear regression methods, first we need to obtain our experimental data. So when we go to our GitHub website, we will have a water vapor pressure file. So this is a CSV file, which stands for comma separated values. So the values are separated into different columns using commas. So on the left column we can see the values for the temperature, and on the right column these are the values for the pressure. So we'll just copy the link, go to our collaboratory. So we'll use vget to import our data to Google Collaboratory. So as we're getting. So as we will be working with the numbers, we will also have to import numpy to our collaboratory. So import numpy as np. And also we will have to plot our data. So for our plotting purposes, we will be using something called plotly. So this is a library. So we'll be using subplots. So we'll be using plotly subplots. So to do that, we'll have to import this to our collaboratory. So I'll just copy that and go to paste it here. So, and I also want my background to be dark when I'm plotting, so I'll just say import plotly.io as bio, and file templates default would be equal to plotly dark. So I will just run this. So now as we imported our data to our collaboratory, now we have to import it as an array to work with that. So we'll just say, we'll just have a variable called data. It'll be, we'll use, in order to get an array, we'll use something and numpy load txt function. So inside of it, we need the name for our file. So it was water vapor pressure CSV. So we'll just copy and paste it right here. And here you can see we also need a delimiter, which is delimiter is something that the values are separated. So as it is CSV file, they are separated with comma. So our delimiter would be comma. So we'll just run. So delete. So there's a typo, delimiter. Run. So now as we want to see our data, so this is important as a data into columns. So now as you can see in the left column, these are the values for the temperature and this is the pressure. So we'll just get this separated into two different variables. So we'll have T. So from data, we'll get only the values in the left column. In the Python, the indexing starts from the 0, so the first column would be marked index as a 0. So for the pressure, we'll get from data, we'll get only the values in the second column. Just run. However, as we go to our Antoine equation, we can see that this is a relationship between the temperature of a substance and a log base 10 pressure. So we cannot just say it is the pressure. So we'll just use log 10 pressure and here NP log 10, which would calculate the log of all the values in the list. We'll just run it. So let's just start from plotting our data, raw data first. So we'll just have a figure, make subplots. So here, make subplots. Here we say fig add scatter. So see there's an error. Subplots. So this is a typo, so that's why it was showing an error. So in our x-axis, we want our temperature, and we want the log 10 base pressures in our y-axis. And for the mode, we will say that they are markers, so they will be marked as dot points. And for the name, we'll just call it data. When we run this, so we forgot something. Figure scatter. So here we see our data plotted using the scatter plot. So now for nonlinear regression method, we would use the minimize function and the subscript error. So we will find the values for ABC where the subscript error is the minimum. So let's just first start by defining the function subscript error SSE. So it will get vector, and so for our vector, let's just unpack it. So we'll have a, b, and c equal to our vector. So our function must return the value which is sum of all the subscript errors. So we'll just subscribe from our model the log time based pressure. So our model is from Antoine Equation. It is a minus b over c plus t right here. So we'll just go a minus b over c plus t. So from our model, we'll subtract log time based pressure, and we will square it. So now if we run it, so now we have our function that determines the subscript error. So to get the values for ABC, we have to use a function that will minimize the subscript error to find the values for ABC. So to do that, we can use something called scipy optimize minimize. So this is a function that minimizes our function to find the values. So before using that, we should import that function here. So from scipy optimize, we should import minimize function and just run it. So here now we can calculate our minimize function, which would be, it'll get our subscript error, and we should give our initial guesses. So it's 1 for B, just 1 for C, it would be just 0. So actually our initial guesses affect the how our function will work. So if our guesses are too far from the original answer, it will say an error message. So minimize, let's just run it. So here it calculated our ABC values. Here, as you can see, under the X array, we have our A, B, C values. So let's just unpack it, but when unpacking it, we cannot just unpack our minimize function because it will say an error, because we only need the values under the X. So if we just run it, it will say an error. So if we include dot X right here, it will only get the array under the X. So now we can have our A, B, C values. So that's values we obtained using the minimizing our subscript errors. So let's check if our values support our data. So we'll just plot another graph. So add scatter. For the x, we'll still have our t values, and for the y, we will have our model. So which was a minus b over c plus t. And for mode, we already used the markers, so we can say lines. So they will be represented as lines. And for the name, we will have Antoine, just non-linear. We'll just plot that. So it says an error message, so there must be a typo. So scatter. So we forgot this. So here we go, our data. So which means the values we got for ABC actually support our data. So this was the method to obtaining values for ABC using nonlinear regression. So now we'll be looking at another method using linear regression to get ABC values. So to solve our Antoine equation using linear regression method, we have to set up our design matrix first. So our equation for Antoine equation was log 10 base p equals a plus b over c plus t. So as you can see, we have one parameter in denominator, so which means we have to use common denominator method to set up our design matrix. So if you multiply c plus t to to both sides, you will get c plus t log 10 base a c plus t plus b. And if we open the brackets, we have c log 10p plus t log ac plus at plus b. So if we arrange our equation in a different method, we would have at minus c log 10 base b plus ac plus b equals t log 10 base b. So we are given t log b and these things. So now we can set up our design matrix to be, so here we can have our t values, t2, t3 up to tn. So then next we can have negative log 10 base pressure. So 10 base pressure 1, log 10 pressure 2, and up to negative log 10 base pressure n. And we have AC plus B. So that we can call it D. And for our design matrix, we can include like ones. So it would like, and if we have our vector A, C, D, so it would multiply with everything. So using matrix multiplication, we should get our vector t1 log 10 p1, t2 log 10 p2, and up to tn log 10 pn. So if we just call it as a cube, this matrix, this would be our vector, and this can be our b. So we'll have qv equals b. So this will be our design matrix. However, this matrix is n by 3 matrix, and this is 3 by 1, and this is n by 1. So these matrices are overdetermined. So if we multiply q transposal to the both sides, we can have something like q transpose multiplied by q multiplied by v equals q transpose multiplied by v. So we'll have something that we can find the value of using the coding. So this would be our design matrix. We can now use the Python coding to find the values a, b, d, and then, as we said, d equals ac plus b. From the d value obtained, we can find b to be equal AC minus D. So using this design matrix, we can evaluate all the values A, B, C in using the Python coding. So solving Antoine equation using linear method wouldn't need so much coding. So first we need to have our design matrix here. So it would be dot C. So this is a function that translates the function in different arrays. So here we go. We had in our design matrix we had our T, and then we had our negative log, then pressure, and then we had ones in our design matrix. So here and numpy would say we'll use the function numpy ones like. So it would just show us the ones, and we should specify the length, so it would be in the same length with the T. So run. So now it's good because we use different class here. So when you check our queue, here we have our design matrix. So to solve that, we would use our numpy lin alg function, which would solve our linear algebra. So in order to find our vector, we have to multiply both sides to the Q transposal. So we'd have Q transposal multiplied, so add is used as a multiplication when working with matrices Q. And then for the another side, we had our T log 10 P multiplied to Q transpose. So we'll just run that. So yes, here we forgot we should have multiplied Q transpose at T multiplied by log 10P. So run. It's not called. Yeah, I see we forgot ours. So here we go. We got our values for A, B, C. Let's just unpack it. So we'll have, let's now call it as A2, B2, and C. We have D2. So, and to find B2, we would use A2 multiplied by C2 subtracted D2. Oh, this was our C2 value. So run. So we got our values, so let's just plot it. So first we'll try to plot it in the same scatter plot. So this time we would have 2's here with same lines. We want to be as lines, so this would be called Antoine using linear regression method. So plot it. Here we go. We have our plot. So the green line represents our linear regression. So here, as you can see, it's exactly at the top of our design experimental data, and our nonlinear regression line. So which means our A, B, and C values are obtained correctly. So here you can see there is a slight error, which is because of the experimental data. So thanks for your attention. So this was explanation for obtaining values ABC from Antoine equation using linear regression and nonlinear regression method.